Okay, so let's look at writing inequalities that are one step with subtraction. So in the first problem we're going to look at, it's kind of tricky. It says the weather forecast predicted that the evening temperature could get as low as negative 12.5 degrees Fahrenheit. Between the afternoon and evening, the temperature dropped 7.5 degrees. What could the afternoon temperature have been? So I know that negative 12.5 is like the final result. And that's if the temperature drops, so as low as it can go. So that's a pretty low temperature, negative 12.5 degrees. Freezing is 32 degrees, so it did not get this cold this past winter. So that's as low as it can go. That means the temperature started off higher than that. So the temperature, so I'm going to use X is the previous temperature. And that was higher or greater than negative 12.5. And then the temperature dropped some, but never getting as low as, any lower than that. So that's as low as it can go. So when it dropped, it dropped 7.5 degrees. So as I read this in order, there was a temperature, X. The temperature dropped 7.5 degrees, let's subtract 7.5. And now the result could be as low as negative 12.5. So here's my inequality. So this part here is called the inequality, and I've written my inequality. Now I'm going to solve it. So I'm going to solve it by using the opposite operation. The opposite of subtract is to add, so I'm going to add 7.5 to both sides. Now when I add 7.5 to negative 12.5, that's going to give me a negative 5 degrees. Okay? X is supposed as X over here, and I'm going to bring down this inequality symbol, so X is greater than or equal to negative 5 degrees. That means the previous temperature when it first started could have been as low as 5 degrees to start, but it probably negative 5 degrees, which probably wasn't. So what I'm going to do now, this is the tricky part, I'm always going to put a number on both sides of my inequality. I'm going to put a number that's greater than negative 5. Now, a number that's greater than negative 5 is 0, so I'm going to put 0 over here. So 4, 3, 2, 1, 0. And I'm going to put a number that is less than negative 5 to the left of negative 5. So that would be, I'm getting further and further than the negative. So negative 5, negative 6, negative 7, negative 8. I'll put negative 8 over here. Okay. Then I look back at my solution. This is called my solution. X is greater than or equal to negative 5. There's my solution. So I'm going to graph that now with my sign here. It could be equal to 5 or greater, so that's to the right. And I'm going to check it. Like I'm going to pick a number over here. Like let's say it was 0 degrees. If it had been 0 degrees at the start and then dropped 7.5 degrees, would that still be greater than or equal to negative 12.5? This is me checking my solution. Well, this would be negative 7.5, and negative 7.5 is greater than negative 12.5 because if just think about it, negative 7 degrees is warmer than negative 12 degrees. So this is the correct way to graph. So we have graphed our solution on the number line. We've written our solution here, and we've written an inequality. Let's try one more word problem. The speed limit on a road drops down to 15 miles per hour around a curve. Mr. Gerard slows down by 10 miles per hour as he drives around the curve. And he never drives above the speed limit, meaning he's never going to actually drive above the 15 miles per hour. Now listen, before the curve, he was driving above 15 miles per hour. Okay? Because before the curve, the speed limit was different. So he had a different speed limit. We don't know what it was. We just know it wasn't 15 miles per hour. It was probably higher than that. So what we're going to do is we're going to write an inequality to show his speed. X is going to be his miles per hour before the curve. He was going a certain speed. Doot, doot, doot. He dropped his speed. He went down 10 miles per hour so that he could get to the speed limit that was 15 miles per hour. Okay, so he decelerated to get to 15, and he's never going to go over 15. So that means his speed is going to be less than or equal to 15, because he's never going to go over 15. So now that I have my inequality, so I made an inequality, there it is. Now I'm going to solve it. I'm going to add 10 to both sides because that's the opposite, and this is going to seem strange, but so that means x is less than or equal to 25. See, here's that solution. And you might be wondering, well, how is your solution more than 15 if he never went over the speed limit? Remember, before the curve, I'll just draw this little road here. It says road, road, okay? And then it goes around a curve. So right here, this part of the road, he was going like 25. Or maybe he's even going, so he's going, say, 25 miles per hour, okay? Here he's going 25 miles per hour. Then he hits the curve, and this slows down. So now he's slowing down to 15. Okay, so that's why it was more there. So when I graph the solution, I'm going to graph things that are to the left of 25. So I wrote 25 on my number line. I put a closed circle because 25 could have been the speed he was going, or he may have been going less than 25. We know he wasn't going over 25 because here's why. Let me try 30 here. Let's say he was going 30 miles per hour before he hit the curve, and he decelerated by 10 miles per hour. Then, if he only went down 10 miles per hour at the curve, then he would be going 20, which would be over the speed limit. So he wasn't going 30 miles per hour or 35. He must be going 25 or less. Because if I use 30, it will meet my inequality. So now we're just going to look at two of these problems that are just problems without any words on them. So if I'm looking now here at number, or letter B here, letter A, and we're solving, we're just going to solve by using the opposite operation to both sides of the inequality, and we're just pretending like it's like an equation. So I would have x is greater than, and this is going to be 8.9. And then to graph it, okay, I'm going to put 8.9 on the number line, and then I'm going to put a number to the right, so I'm going to put 9 over here, and a number to the left, maybe 8.8. Okay, then at 8.9, I'm going to erase this line that I wrote because that's too big. I'm going to draw an open circle because it's not equal to. So there's no line here, so I leave an open circle. And then I'm going to go to the right because it's greater than. And then I can check my solution, and I check it like this. I take a number where I shaded, so like a number like 9, anything on the right here, and I'm going to substitute it in. 9 plus 3.5 is supposed to be greater than 12.4. Well, this would be 12.5. Is 12.5 greater than 12.4? Yes. So this checks, it's true, so that means I graphed the right way. Let's try on this side. This one will be a little trickier. So I'm going to draw my line down. I'm going to subtract 17 from both sides. There's a couple places to get mixed up here. First of all, negative 10 minus 17 is actually negative 27, not 7, not negative 7. Negative 27 is negative 27 is greater than or equal to y. So now when I go to graph this, and I put negative 27 here on the number line, this gets a little tricky because I'm in the negatives, so I have to think of a number that is to the right. Well, I'm working towards 0, so like 0 is like way over here. So this would be negative 26, here's negative 25. And then to the left, I'm getting further to the negative, so 28, negative 27, negative 29. Sorry. And I'm going to put an open circle. Now let me see, a closed circle, because it's equal to. I keep saying the opposite thing. I'm there now. Now I'm going to see which way I should shade. Well, if I'm going by this symbol, it looks like I should go to the right. Let me check to the right. If I go by the symbol, it looks like to the right. Let me check that. So negative 10 is supposed to be greater than or equal to y, which is, I'm going to use negative 25 here, negative 25 plus 17. Well, negative 25 plus 17 is negative 8. So negative 10 is not greater than negative 8. It seems like it is a bigger number. Remember, we're in the negatives, so 8 is actually greater. So the right is not the right way to shade. Instead, I should shade to the left. And here's why. Y is not what's greater. Y, see how the alligator's eating the negative 27? Let me write this in the other way. Y is actually less than, see how the little end is pointing towards the y, is less than or equal to negative 27. So now my solution and my graph matches. So you might want to rewrite it with the variable on the left. So to sum it up, you want to make sure that you have a solution, which is an inequality, right, with the number, and you want to make sure you have a graph. Oops, don't color it in. Don't color that in. And then over here, you want to make sure you have an inequality in your graph, and they should match. Thanks for watching. Bye.